All right, thanks everyone. So firstly, welcome to today's panel discussion on cybersecurity in digital manufacturing. Today's topic is going to be on the role of professional societies. I am Dr. Hammond Pierce. I'm a postdoc at the New York University Tandon's Department of Electrical and Computer Engineering, Center for Cybersecurity, and also I am the moderator for this event. First, I'd like to acknowledge our sponsor, the National Science Foundation, who makes these kinds of events possible. Just a brief introduction. Traditional manufacturing is increasingly being supplanted with new technologies. Factories are becoming smarter and more interconnected, and new manufacturing techniques are increasingly being adopted. For example, 3D printing and smart hybrid manufacturing. With these new advances comes new risks, especially within the cybersecurity domain. Across this panel series, this cybersecurity webinar series, the NYU Center for Cybersecurity is hosting 4 discussions with experts from academia and industry. All of these events will be recorded and made available on YouTube. The panels are an opportunity for you as an audience to directly ask questions to some of the leading experts in the field and also learn a few things from their presentations. This is the first webinar in the series this year. It has the focus, as mentioned, on the role of professional societies in this space, their contributions and how they move the sector forward. We hope the information that emerges from these events can guide some of the future research efforts in this area and make research relevant to the needs of industry. We're fortunate to have 3 eminent panelists with us today. I'll briefly introduce each and then they'll take over and talk about their areas. Firstly, we have Raj Manchanda from the Society for the Advancement of Material and Process Engineering, or Sampy. Raj serves as the Chief Technology Officer at Sampy North America. He's responsible for overseeing all technical aspects and technological resources and establishing technical programming strategy and execution for the society. His team also ensures technical relevancy by conducting research to ensure Sampy North America's technical programming is relevant to market needs. Prior to joining Sampy, Raj was a training, brand, and alliance executive at Hightalk, an industrial bolting systems manufacturer. Additionally, he's also held various positions for over 20 years at the American Society for Mechanical Engineers. Secondly, we have Dr. Maddie Jamshidinia from the American Society for Testing and Materials, or ASTM. Dr. Maddie is the Additive Manufacturing R&D Project Manager for ASTM International. In his role, he brings technical expertise to accelerate standardization activities through leading R&D projects, identifying future R&D needs, and forming new collaboration initiatives with technology experts. Previously, Mahdi has worked at EWI, where he led the DMLM team in Columbus, Ohio. Next, he worked at GE Additive as a staff engineer in the materials technology team and led the response surface activities. Among other things, Mahdi established multiple partnerships with universities and government agencies for using machine learning and data mining in alloy design, process parameter optimizations, and in situ monitoring. Finally, we have Professor Chi Zhu representing the Technical Committee for Cyberphysical Systems, or TCCPS. Chi is an associate professor at the ECE department at Northwestern University. His research interests include designing automation for cyberphysical systems, or CPS, and Internet of Things, safe and secure machine learning for CPS, cyberphysical security, and system-on-chip design, with application in domains such as connected and autonomous vehicles, energy-efficient buildings, and robotic systems. He's a recipient of the NSF Career Award, the IEEE TCCPS Early Career Award, and the Humboldt Research Fellowship for Experienced Researchers. Among other things, he is the conference chair of IEEE TCCPS and the vice president of young professionals at IEEE CEDA. He is an associate editor for IEEE TCAD and IET Cyberphysical Systems, Theory and Applications. I'm pleased to welcome these panelists. They're experts in their fields. Now I request each panelist to take a few minutes to give an overview of their work related to the area of cybersecurity and additive manufacturing and how this can intersect with their professional societies. As a reminder, attendees can ask questions at any time during this presentation, and we encourage you to do so. Just use Zoom's Q&A feature. And we'll take some of the questions as we go, moving into the panel discussion after the attendees have introduced themselves. So let's start with Raj Manchanda.
Thank you, Hammond. Thank you, Nikhil, for organizing this wonderful program, very timely. I do have some slides I was going to share, and for me, what I want to do first is start with what is Sampy? Many of you may not be aware, and I think the reason why it is somewhat significant is because the stakeholder community are the folks involved in manufacturing. So Sampy, as Hammond previously mentioned, is the Society for the Advancement of Materials and Process Engineering. We have about 5,000 members. It is a global organization, primarily separated by regions. So North America, Europe, China, South Korea, Australia, etc. Excuse me. And I think, folks may think, so this is all about composite engineers. Yeah, that's somewhat true. As you go through your undergraduate training, you typically are exposed to the metals world, as most of our panelists and probably our attendees are. So Sampy focuses on composite engineering and all the opportunities that composites bring to the manufacturing world. More about the organization. It is very driven at the local level. So professional chapters are, many of the other societies may call them divisions, etc. But at Sampy, they're called chapters, very active, and they do their own programming. For us, we do have a journal, and it's a bi-monthly technical publication where topics such as these are covered. So I just wanted to raise awareness of the journal. The other major activity of Sampy is called CAMEX. It's the Composites and Advanced Materials Expo, and I'm really pleased to share that for this October in Dallas, a in-person activity is planned. There's a little screenshot at the bottom of this graphic, and it shows something like 200 exhibitors in person will be there. So, we hope some of you may be able to join. Here's some information about myself, but at the end of the day, what this is about, what I will talk about as the panel gets going, is NIST Special Document 800-171. And that talks about controlled unclassified information, CUI. So that's what the talk will be, Hammond. Thank you very much for the opening remark.
Thank you so much. Dr. Maddie, would you like to briefly introduce yourself?
Sure. Thanks, Hammond and Dr. Gupta for the invitation and putting this event together. Similarly, I would like to share some slides. All right, can you see my screen now?
Not yet. There it goes.
Very good. I'm sure many of folks in this panel and the event know or heard about ASTM. We are a standard development organization established in 1898, about 120 years ago. This activity, this standardization activity, resulted in having more than 12,000, close to 13,000 standards. And that certainly has been possible through voluntary contribution of our members. Currently, we have over 30,000 members, and ASTM standards are being used in 160 countries in various sectors, close to 90 sectors, from oil and gas to aviation to consumer products and others. And ASTM has around 150 technical committees. My background is in additive manufacturing. There are more than 20 committees that are relevant to additive manufacturing or are somehow contributing to additive manufacturing. But there is one committee that was formed in 2009 specifically for AM, and it is called F42. In addition to what we do at ASTM for AM, there is a lot of collaboration and partnership in various forms and levels that happen with other organizations. And really the objective is avoiding duplication, avoiding confusing the community. So we want to have one voice out and helping the adoption of different technologies. So on top of what's happening at F42, in 2018, ASTM decided to form the Center of Excellence, which the team that I belong to. Really the goal of this center was accelerating the standardization process. There are various reasons. If you've been involved with the standard, you know that it's a slow process, and there are various reasons for that. One of them is lack of publicly available high quality data. So our objective at the Center of Excellence is generating that data through short-term and focused R&D and providing it to committees so that they can go ahead and develop the standard. There are some activities on cyber, on various forms of the standardization, on the education and workforce development, but if time permits, I certainly get to that. Thank you.
All right, thanks for that. And finally, can Professor Chi just briefly introduce yourself and your society?
Let me share my slides. I have a few. Can you see my slides now?
Yes.
All right, great. So Hamid, thanks a lot for the introduction, and thanks for the invitation from you and Professor Gupta. It's my great pleasure to be here, and I'll start with some introduction on the IEEE Technical Committee on CPS. So this is a technical committee established several years ago to coordinating the technical activities related to the design, implementation, operation, validation of cyber-physical systems, where the emphasis is on the designing of the cyber components for sensing, computation, communication with sort of close interaction of the modeling of the mechanical components and the physical environment and process. The technical committee right now has more than 50 members across the world from major universities and some of the industry participants as well. And the activities involves, there's a large range of activities, for instance, organizing special issues for major IEEE and ASTM journals, and organizing conferences and the workshops, and in some cases special sessions in conferences. Several awards have been established and awarded in the past several years. For instance, here you can see those are the past recipients for the Technical Achievement Award, the flagship award in the committee, awarded by the committee, Professor Alberto San Giovanni Bensantelli, Professor Edward Lee, and Professor Jamel Ding. There is outreach activities to other societies within IEEE, for instance, Industrial Electronics Society, Technology and Engineering Management Society, and there's significant outreach to other organizations outside of IEEE, for instance, Institution of Engineering and Technology, ASTM, and the International Council of System Engineering, etc. And the goal for TCCPS is really to serve as this hub for the international research and engineering community for cyber-physical systems. So relevant to today's topic, there has been a number of activities, in particular in terms of journal special sessions and conferences, symposium, and workshops organized for cybersecurity and for industrial cyber-physical systems, where it's more relevant to smart manufacturing. And some of those, especially more recent ones, are listed here. You can see two ongoing efforts. One is on the cybersecurity side, on the security, privacy, and the trustworthiness of intelligent cyber-physical systems and IoTs. And then on the industry CPS, there's ongoing special session for machine learning for resilient industrial cybersecurity systems. Now, both types of activities we have seen sort of relevance, especially actually on the recent activities on industrial CPS is very much relevant to manufacturing. And we very much look forward to sort of bridge those two important aspects, security and manufacturing, through our activities and collaboration with others. So hopefully today will be a good forum to discuss how this can be done. Thank you.
Thanks so much, Professor. Okay, so moving on from here, we're going to open the floor for sort of a general discussion for everyone. I really do encourage the audience to ask questions through the Q&A system based on any topics that we're talking about, any follow-up questions you might have, and if you want to add more questions for people to talk about as well. So just sort of begin with, this sort of is a question for everyone, so just sort of take turns answering. What are some of the flagship programs? You've mentioned a few in terms of your symposiums and workshops on your slides, but what are some of the real flagships that if someone was going to come up to you and ask, hey, what's a really showy example of what we do? What would you point them towards?
Yeah, Hammond, I'll start. So this is not a Sampy program, but it's a NIST program. But I think, for folks out there, for manufacturing enterprises, to have awareness and knowledge of the risks involved, as manufacturing becomes more and more digitized, and, we're very concerned, obviously, with quality, but what about security? What about authenticity? If you're printing a part for a client, how do you know what it is? So I really would like this panelist and the folks on this webinar to look into the NIST document, the 800-171 special publication, because if you're interested in any kind of DoD work, you will have to comply. If you're not doing DoD work, it'll provide some very good guidance. And there's some resources that I'll put up in the chat. There was a free workshop that NIST did on this program just recently, so I'll put it up on the chat before we conclude. But you have to know what you're manufacturing. You can't just we can't be careless anymore. We have to be extra vigilant on cybersecurity, and that's why I think you brought us together.
Yeah, great point, Raj. Absolutely important. And the document has been developed with the input from the industry as well and the broader community. So this is a resource for us, everyone, to use. If I want to expand on what Raj said and some of the activities that we are doing, is it okay if I share a screen again?
Yeah, you can.
Yeah. So let me try. So let me know if you can see the screen.
Yes, got it.
All right, very good. So there are a few things that I wanted to touch on. Some of the resources, additional resources that are available to the public right now are 5 standards that we have. So you probably see that 4 of them are published already. 3 of them are from 2020, and this is still being developed. So this is a very new topic, cybersecurity. The research or the fundamental study has been going on for a while, certainly, but then the community got to a point that the need for a standard is there. To Raj's point, if you want to be compliant, there are needs for a standard. If you want to certify your product, if you want to qualify your product, you have to have a standard and follow it. So this is a resource that I'd say folks can use. Another item that I wanted to mention is the conference that we have on additive manufacturing. Certainly the topic is AM, but additive is a multidisciplinary technology. You need to know design, you need to know material, you need to know testing, data management, and cyber. So many things are happening in the digital area, and we want to be careful about it. We want to protect it. So this year specifically, we added a symposium for cybersecurity in AM. We're going to look at connectivity, security. What are the challenges with respect to cybersecurity, and how AM community needs to adjust with respect to that? And what are the standardization needs? Are there topics that we have enough data, we have potentially enough consensus, so a document can be put out as a guidance for the general community, especially the small size and medium sized companies that may not have all the infrastructure to develop their own technologies. One other item that I can touch on is our work on education and workforce. I can expand on this topic later if this is of interest, but specifically for cybersecurity, we received the funding from America Makes late last year to develop a course for cybersecurity in additive manufacturing. It is going to have two sets of materials. One is going to be for executives. So if you're in charge of an organization, what are the risks and how you should go about protecting your organization and stakeholders against it. And also, if you are a subject matter expert, there's going to be a separate course that we are going to develop. As of now, we're planning to offer this course in the week of May 10th, and after that's going to be available online. So I guess these are a few items that I can mention, but if there's interest, I can expand on these topics.
And Hammond, I was just going to say, you know, I think the resources from ASTM, and I think Chi will also talk about IEEE and Northwestern, but the resources are outstanding, what's out there. I think the challenges for manufacturing enterprises as the digital technologies come into play, you know, such we at CAMEX will probably see 400, 500, 600 exhibitors in a good year, maybe not this year, but hopefully they'll come back. As they scale additive and other technologies, you know, this has to be part of your checklist. You can no longer say that the security is not relevant. And I'm not saying I think folks have to comply right now, but I think with the NIST document, you can just be aware. You know, you can be aware of what their requirements. Some of the larger organizations, they probably don't have these issues because they probably have resources in IT, et cetera. But if you're a small, medium, less than 100 employees, you don't know where to start. You know, one place where I would say you should start, obviously ASTM has resources, but the NIST document has a checklist available. You know, you don't have to go for a third-party audit right now because that would be an investment, but get the checklist. You know, start with that.
All right, thanks so much. Professor Chi, did you want to briefly?
Yeah, just to add on to those a little bit. I mean, I think for IEEE TCCPS, right, our focus, at least so far, has been very much on the research side. And what I think here is very interesting is if we think about the cybersecurity for AM, right, this is very naturally it's a cyber-physical system. There's strong side on both cyber and the physical. And so it is a topic I think very much we hopefully, I mean, we should actually from TCCPS perspective, right, to emphasize and to promote in our technically sponsored conferences and workshops to tell researchers, right, there are challenges and interesting problems to address here, and what at least what I see that's very interesting is the nature of those being cyber-physical systems. There are challenges that sort of beyond the traditional cybersecurity challenges, right? They often across cyber and the physical domain, they become challenges on cyber-physical security. And for topics like those, I think would be really interesting, I think, for us to explore more and maybe to organize the sessions or even dedicated workshops to discuss those both across academia and across industry, and hopefully with input from Sampy and ASTM, and to really understand the domains. And I think that would be beneficial.
Thank you. Hey, Chi, I'm sorry. I was going to ask, have you heard what they're doing with Oak Ridge at the manufacturing demonstration facility on the hybrid manufacturing? Have you heard of that yourself or Mahdi? Is this whole cyber security, cyber physical, is that also relevant to hybrid manufacturing?
So I know Oak Ridge has some activities on cyber, certainly. They, I believe, held a workshop earlier part of last year, but I'm not sure if that cyber activity is relevant to the center that you mentioned.
I see.
Yeah.
Yeah, I'm not aware of this as well. So if Raj, you can explain a little bit more, that'd be great.
Yeah. No, I think the hybrid manufacturing, what I was seeing was there were some machines out there. There was a Mazak machine, and not only was the additive component built in, but also the subtractive component in one machine. So I saw that there was a demonstration. It was fascinating, but I think as Mahdi, you're saying, I don't know what they are thinking about the security piece, but I would imagine you have to. You have to, because my design, if I'm a designer and I put my AM design out there, I want to make sure that design is what goes to print.
Yeah, you want to make sure that there's no flaws embedded into your file, and then you put that part in the service. That's obviously a big concern that we've been seeing. One of the challenges, I think we talked about SMEs, right? One of the big challenges that exist is that many organizations or many active players don't really know where to start from. Right? This topic is large. I think last year I learned that it is not only cyber challenges. We have physical cyber challenges in AM because we have machines. And once we were discussing with experts in the field, we realized that folks are using different terms or same terms and different definitions, right? So I'm again looking at it from the additive manufacturing perspective, but I think it applies to all different technologies. So there should be a common language between cyber experts and experts and other technologies. And we need that education to happen. We need some workshop. We need some brainstorming session, road mapping sessions that can bring experts together, all the key stakeholders, and government certainly needs to be involved in these meetings and in these discussions. So this is what we've been seeing.
Just to interject, I've got a question related to this from the audience, which is basically along the lines of if this, if this is quite difficult to get your digital manufacturing going or your hybrid manufacturing going, what are the motivations? Why are people switching to cyber physical systems for manufacturing and moving away from your traditional manufacturing? What are the advantages?
I'm going to let Chi talk because I think he has some expertise, but I would say cost and speed to market. The days of saying a prototype will take me a week or so, or get a mold done for a tool in a few weeks, they're gone, my friends. That is gone. The marketplace is really sophisticated now, and there are players out there. I know where Mahdi came from, GE Additive, they could probably turn around parts just like that. So speed to market, cost, I think those are huge. But Chi, please.
Oh, I think I think this is the question probably, for you guys who are more familiar with the sort of industry thinking, right, would know better. But for us who are researching in academia, we always view this as provides potential improvement on sort of improving the sort of flexibility and adaptability, right, of your manufacturing, and where you can quickly adapt to different manufacturing needs and get the products off. Right?
Right.
In the,
I think I think that also goes along with the new world order where, it's not like Model T Ford where you just manufacture thousands and millions of a product that looks the same. Now the world is, you have 787 Dreamliner one day, and now Boeing is probably investing in their next product line. So quickly the supply chain has to adapt. So I think this is where the cyber physical models would be very valuable. Imagine if all that was done as physical product, using data as I think all the panelists agree that that's the key. High quality, good data, then you can build upon that. But Dr. Pierce, is that what you were thinking?
Yeah, I think that's very appropriate. I think building on that then is the next question, which is Mahdi mentioned the term adjusting cybersecurity to additive manufacturing in his previous slides. He talked about how it was an adjustment process. So what are some of the differences that you see in this modern manufacturing paradigm with the approach to cybersecurity? Was there even a concern in traditional manufacturing around cybersecurity?
Yeah, what I'd say is that there are many, so this kind of relates back to the previous question. Why should we bother about digital manufacturing, right? Because it just makes it probably simpler and easier if we have the right infrastructure and the right firewalls in place. But then when we want to take the advantage of digital manufacturing, at the same time, we have to be able to protect it. So in AM, what we have is design, and then you have powder, you have machine, you have testing, right? There are various steps that data can be missed or misrecorded or manipulated. So I'd say one of the characteristics of AM is so many steps that is involved in this process. And there are many ways that something can go wrong. One other uniqueness that AM has with respect to other maybe traditional casting or forging methods is that we generate the material, we make the material in the process. So in the traditional way, you would cast, let's say, steel, you would get a grain size, a microstructure, and you would get a certain property. Then you would go out and machine it. So what comes out of machining is most likely similar to the casting microstructure. Whereas what is happening in AM is that you get a powder, you melt it, you make the new material. And then depending on your geometry, your material characteristic is different from left to right, from bottom to top, from thick to thick section. So there are a lot of variations in AM that if we do not pay enough attention to, can go wrong. So I think this is why make cybersecurity important for us.
Yeah. And I wanted to add, so it really comes down to materials. My organization, we work on materials. Who in this panel or in the audience will say materials development is easy? It's not. It's a very costly process, takes a lot of money, a lot of time. And, think about it. How do you, the qualification of new material is immensely a huge project. I can't, if I'm Boeing or Airbus, I want to put up a new composite, I can't just do that. The regulatory environment, the qualification, as I mentioned, is critical. So without the proper cybersecurity checks in place, you can't even get there.
Yeah, I'd say in some cases, the regulatory agencies haven't got to that point yet.
Yeah.
So we were doing a project on using in situ monitoring for qualification of AM parts. It is a very expensive process. It is time consuming. So the idea was to use monitoring to facilitate that process. Our regulatory agency's mindset is not prepared yet for monitoring. I don't want to say that the monitoring technology is ready, but that wasn't the only problem. I think that's the case with cyber as well. So we need a lot of education before really cyber gets implemented.
All right.
day in, day out.
So to add on to those, I think what's interesting here really is for security for EM, right? It's both security for data on the more traditional cyber part, and also security for the physical process, right? And possibly security challenges across those two domains. And this what we have seen sort of in many of the other sort of cyber physical systems. They do have some of their unique challenges. In some cases, your initial attack may be coming from physical domain, where the traditional, for instance, the sensors, right, may be attacked. Then your sensor input may be wrong to begin with. In this case, more traditional cybersecurity techniques on authentication, on decryption base, they can't really tell this is wrong, right? And another aspect is to apply some of those cybersecurity techniques. They incur sort of a timing and resource overhead, right, to your process. And sometimes that may have a negative impact. So you have to trade off between the level of protection you want to provide, and on the other side, the overhead that you incur. And then I think you guys touched upon the machine learning aspects, right? I think that's also very interesting. I think it brings both opportunities and challenges. On the opportunity side, maybe based on those data-driven approach, we can develop new techniques, right, to detect anomalies and to mitigate them. But on the other side, the current sort of lack of methodology to predict, for instance, neural network behavior also brings this challenge, right? When we put neural network in our process, do we really know what it entails when they generate certain outputs? I think those are all very interesting challenges, and possibly very unique to some of those domains.
And ultimately, I don't know if everyone would agree, but it's application driven. You know, if you're making a widget that you're going to sell at Home Depot, that's okay. But if this is going into the new Acela train and, you know, it's a production part, that's an issue. And I think so, you know, as Hammond, I think you mentioned this before, but it's the market is changing. You know, the demand from, I want the best mechanical properties out of my new materials, and I want to be able to prove it. So if I can do all that, but that takes a lot of money. So I think if the cybersecurity piece and also the cyber physical world that she is talking about, if that can help reduce or shrink that timeline or I guess overhead and testing, that would be very positive.
Yeah, so one of the questions that's been raised is sort of touching on the intersection of the different organizations. So, you know, in this panel, we've got an academic, you know, primarily focused on research, and then which is TCCPS, and then we've got ASTM and Sampy, which are more focused on the industry side of things. And how do you see you know, the intersections of these working? How can we approach things like data sharing and standardization between the, you know, you mentioned earlier around, you know, different organizations and different companies are using the same words that mean different things, or different words that mean the same things. What's some of the ways that we can work towards, you know, rectifying this?
We're going to have a next workshop that Professor Nikhil Gupta and your team organizes on nomenclature, you know, getting nomenclature to be common. But I think you're onto something. You know, we all do work together. Even now, Mahdi and our groups work on CMH17. You know, Sampy has some technical experts that contribute a chapter to that handbook. So it is a very connected world. Is there more to be done? Yes, there is more to be done. And I think with the fact that you guys, NYU, stepped up and offered such a workshop, you know, this is outstanding. It starts the conversation. So thank you.
I'd like to add that many technologies, if not all, start from universities, academia, right? That's where ideas form. Out of 10, maybe one gets to production, if you're lucky. The practice that we went through for additive manufacturing last year, and that was in collaboration with NIST and the data management group that they're leading, was coming up with a common data dictionary for additive manufacturing. So that kind of refers to the same problem that we have. And I believe the same thing can happen here. Many of the knowledge still exists in the cyber area. I believe it still exists in academia. There are some companies with large R&D funding that have developed their own internal knowledge, but in general, industry has a lot to learn. So I guess this collaboration is essential. One of the activities that we've been doing was reaching out to ASTM members and ask them what are the gaps that exist that we can address at Center of Excellence? What are the ideas that you can propose to us so we can define an R&D project around it and generate the data? Last year, it was very successful. We got a total of 65 ideas from ASTM members from around the world. And out of that 65 ideas, we got 8 projects funded by ASTM. So I guess the same thing can happen and followed by us, by other organizations. It's a matter of engaging academia early on so that when they go through their research, they're fully aware of industrial needs. So they develop something that's going to have end use at the end. Yeah.
Yeah, I would very much concur with what Raj and Maddie said. I think for people in academia, collaborating with industry is extremely beneficial. I mean, not only in terms of specific projects or funding mechanism, but I think in many cases, it's really about learning what are the key challenges right now in the practice and what industry see moving forward, what could be the challenges right in future. And then from there to sort of iron out what are the research topics, right? It makes sense for academia to work on. Right. And what will be the collaboration mechanism? How should we share data on the test cases or even test bed, right? And I think those we have seen when it's being done right, it's really beneficial for both sides.
Right. And Hammond, I don't know if you would agree, and the other panelists, this is really a risk management issue. At the end of the day, it's okay. Some of the terminology is fancy and it's new and it sounds, really great. But at the end of the day, what have companies been doing about risk management previously? I think previously it was very physical based. You lock up your secrets or you have files. Those days are gone, right? Everything is electronic. Designs are electronic. Processes are electronic. So this is a critical topic for going forward, not only for, I think, wherever you are as a manufacturer, but your nation's security. If you're doing any work with DoD, again, I mentioned, I don't think you can move ahead if you don't have compliance.
Yeah, so you sort of preempted my next question there, Raj, but that's fine. There's one from the audience that was basically asking exactly that. So bringing in the idea of risk assessments. As you say, cybersecurity and risk they have such a broad intersection with one another. And where do you think sort of some of the priorities that people should be? This is such a broad area. How do you identify what your organization should be focusing on in general, I suppose?
Great question. I mean, I think we've all seen it's such a fragile world, right? We've seen it in canals, we've seen it with pandemics. It's such a fragile, connected world. So how can you not say, if you're producing a part or a product, how can you not be fully aware of what you're doing? So that's where the cybersecurity comes in. And for us, what we're doing with our stakeholders, I call our members and companies, we are educating them. This goes back to what Chi and Mahdi were talking about. We are putting on workshops. We are within our journal. We're going to have some articles on this. And really for folks on this webinar and Hammond and Professor Gupta and others, I think this is the community that we need. We all need to come together and say, what are the pain points? If I'm a manufacturer in Indiana, what am I working on that is critical? They may not realize it, but if you look at the supply chain, I bet you, there's some point where it makes a big difference. So I want to make sure what they're producing is safe and secure. So I think all of us, we owe it to ourselves for that.
I'd like to add that based on what we've seen, even risk has different meanings to different organizations, right? And impact, opportunity, same way, right? So let's say we come up with 50 topics, right? The question is, with the limited resource that we don't have all the money, we don't have all the expertise, and we don't have time, right? What is the topic that is gonna give us the best outcome in terms of impact, time, and money? So this is the practice that I think various technologies have gone through, various organizations have gone through. We've seen it. I'm familiar with the additive manufacturing space. America Makes is now going through this process. They're kind of updating their roadmap. We've done it for data management in AM. In our processes, the 65 ideas that I mentioned, we receive the ideas, send it to F42 based on a list of criteria. They tell us these are the most impactful ideas that you can find. So I'd say the decision on risk has to be made by the community so that we see the impact at the end. And everybody has to be involved. It is a very hard process. It is a very slow process. But if we want an impactful outcome, that's the way to go.
And I think from, at least for me, from academic point of view, I think one interesting is will risk, is there something that can be quantified, right? Can be quantitatively measured and analyzed together with the benefits that the technology may bring. And is it possible to develop certain methodology to have a more systematic or rigorous way to assess those, right? And this is something always, right, maybe comes to academics' mind of whether some of those assessments can be somewhat based on some general methodology, so we can apply it in different scenarios easily and to analyze them based on the real numbers.
Thanks for that, Aaron. So just moving into the last sort of couple of questions. So if anyone in the audience has any questions that they're thinking of, please put them in now. I think that, you know, overall these are all big societies, and there's a lot of members in all these societies, and there's also a lot of non-members in the societies. So how can sort of everyone contribute to the programs within each of your societies? You know, you have people who are experts who might not know, you know, someone might be in your program but not in your chapter or things like that. So how do you get your sort of people working amongst the different chapters and committees within each society, and also people working outside of those societies that would also like to contribute? Is there mechanisms for that?
Yeah, Dr. Pierce, that's a great question. I'll start. So with Sampy, I mentioned, you know, these chapters locally and nationally. It's very grassroots. So the Sampy South Texas chapter is very involved with NASA, et cetera. So, you know, whatever the community is locally, and you brought up an excellent point. You know, I love our members, of course. I know how Mahdi does too, but there are a lot of folks out there who aren't members. And that's okay. I think if you bring in some expertise, you know, we went from thermosets to thermoplastics, and it's not like thermosets are gone, but that transition, we needed folks from other communities to add their expertise. And, you know, if a forum like this helps bring in some multidisciplinary engineers, that's outstanding. Our website is very simple. I think it's on my background, nasampy.org. Please, you know, come out, send me an email, or if you want to get involved at the major events, they do have committee structures and we do tutorials. But I think the other powerful message is, you know, we have companies who demonstrate or showcase their latest products. I would love for all of us, this group, you know, if we ever had a chance to visit with some of these companies, whether it's at our program or an ASTM, their program later in the year, you know, you visit with these companies, talk about what you're doing, and I'll tell you, you're going to open up a lot of eyes, because the world is siloed. You know, the reality is not everyone knows. So our organization, we are wide open. We welcome folks just to send us an email, talk to our local chapters. But great question on that, Hammond.
I think there's a lot of similarities. The very first step in developing our standards is forming a work group, which basically means 3+ experts getting together, putting some work down, and that's going to become the standard. Certainly goes through the consensus process and becomes finalized. But for that very first step, you don't need to be an ASTM member. You are an expert, and you're willing to contribute to standardization, we certainly welcome your contribution. But again, becoming a member of ASTM is easy. You can go to our website, and it is very affordable. The other point that I want to mention is meetings that ASTM holds throughout the year and globally. On additive manufacturing, at least, that I'm very involved, we hold one meeting in US and 2 meetings a year, one in US, one outside US, so that we get the engagement, the most engagement. There are also workshops and events that we hold. So there are various ways. Membership is the last thing that I would be concerned about if you want to get engaged. If you have questions, reach out to us. We'd be glad to help you.
And I think for TCCPS, we are a part of IEEE, and a lot of our activities are technical sponsorship of IEEE, and in some cases ACM conferences, workshops, and those are places that we try to sort of organizing those activities to get people who are interested involved. We also have a newsletter that's sent out twice every year, and you're very welcome to go to our website and subscribe to that. It's IEEE-CPS.org, I think. And I think events like this is really very good. And I think for a lot of our activities, the goal is to sort of discuss things and challenges, especially at an early stage, right? To get people from different communities together and to brainstorm and to understand each other's challenges and thinking. So I would think some kind of workshop on cybersecurity for EM would be great. I mean, some of those major conferences to get everybody together to have more in-depth technical discussions, right? And so researchers in academia can really understand what are the key challenges in the industry, and the industry can see where and what academics may help, right? And I think that'll be really great.
Chi, you just volunteered. Thank you. I'm going to call up my colleagues who organize CAMX.
It'll be great to work with everybody. Thinking something like this. I mean, we
it's great point.
All the time.
Yeah.
All right, just to fit in one last question before we wrap up. This one is very specific to you, Mahdi. It's talking about F42. So it's a bit of a technical question. Are you working on any F42 standards to do with metal powder and metal powder recycling? And is there any comments on the addressability of sustainability of those kinds of metal powders and things like that?
Good question. Center of Excellence funded 2 projects on recycling of both metal and polymer powders. If you're interested, please reach out to me. I'd be glad to connect you to our PIs and technical contacts. The topic of sustainability actually recently came up at ASTM, so we are looking into it. Certainly there are materials and consumables that are expensive and impact on the cost of material. So the question is, can we do anything about it? please reach out to me. I'd be glad to talk to you about it.
And Hammond, I'm just going to add, I mean, that's a very critical point for us. Circular economy, you know, not only as Mahdi points out on the cost, but what about the environmental impact? You know, it's a time when resources should be reused. So for the composites world, circular economy, very, very important. We are working on that. So if anyone's interested, please let us know also.
All right, thanks for that. So just as sort of closing remarks, I'll just invite everyone to say, you know, 30 seconds, a closing statement on sort of your thoughts and on what we've talked about today. And then we'll wrap up and talk about the next panel as well. So yeah, just in any order, just take, you know, 15 to 30 seconds.
Folks, all right, I'll start. So, you know, I think the panelists shared some resources today. I put some up on the chat, not only Sampy documents, they're NIST documents. There's a lot of information out there. You know, we all are here to help. ASTM, Northwestern, IEEE, Sampy. So we're all here to help. And I think just reach out to us if we can do anything for you. Thank you.
Thanks.
Thanks for putting this together. I want to say that this is not a small problem to solve. We have to work together. If you have ideas for collaboration at any level, we've been doing a lot of different collaborations with various kinds of organizations. Please reach out to us. We'd be glad to have conversation. It may happen now, or we at least know you and know your interests. We'll find each other in the future.
I just want to see that, thanks for the panel and the discussion. I feel that for this topic is very much by nature interdisciplinary topic, right? And so it makes a lot of sense for different societies from and across academia and industry to look at this, work on this together. So I would very much be interested in to look into the future and see whether there's something we can do to facilitate this.
Thanks very much, everyone. So let me just share my own slides again. There we go. So thanks to our presenters. And I'd just like to briefly mention that, of course, this is a series of panel discussions. Today's topic was the role of professional societies. The next society is going to be, the next discussion is going to be on May the 6th. And it is on securing machines and processes. We're going to look at some of the steps and the concrete actions that one should be taking when looking after their own production lines and things that you're in charge of. We've got some exciting people coming in to present at that as well. The link for that is at the bottom of the page. As you can probably guess, the subsequent panels are, you can just increment that number. So cybersecurity AM3 and cybersecurity AM4 at the eventbrite.com links. So once again, I'd just like to thank today's panelists, that's Raj, Mahdi, and Chi, and also our organizers, that's Professor Gupta and also Gary Mack, and finally our sponsors as well, the National Science Foundation, for funding the sorts of programs that make these kinds of events possible. So thanks everyone, and I will stop the recording.